I'm Mike Heimlich here with AWR at the AWR booth at IMS 2009, and I'm talking with Steve Reyes of Anritsu, who's a product marketing manager for Anritsu's VectorStar product. And we're here with the VectorStar itself. One of the interesting things about it is it has the Microwave Office software right on it. It comes with the VectorStar, but the VectorStar in its own right has some really exciting properties. As a software guy that I'm pretty excited about, haven't done measurements myself for a few years, but I remember way back when I was doing measurements, one of the issues we always had with using measurement equipment versus simulation software was that with the simulation software, we really could get almost infinite dynamic range. We could make the floating point accuracy as good or as bad as we wanted. So oftentimes we could simulate things to hundreds of dBCs. And when we went out in the lab, of course, we could only measure 40 or 50. One of the things that I'm really excited about Microwave Office and the VectorStar together is with the 100 dBc dynamic range that we have, I can now see some of those features with filters like we have here that I probably couldn't see before. So that's really exciting to be able to now simulate and measure things together on the same box that previously I maybe couldn't have seen. Yeah,
that's a really good point. And what we've been able to do is not only improve dynamic range in the microwave region, but also improve dynamic range in the RF region. Because up to now, microwave VNAs have had a roll-off situation around 500 megahertz on down because of the couplers they use to separate the signals. Well, what we've done is we've optimized the RF performance by including an RF VNA into the box. So now we're using bridges and mixers instead of couplers and samplers. So instead of having that dynamic range roll-off down in the 500 to 10 megahertz range, we're now going all the way down to 70 kilohertz. So now the device modeling community can see things down to the DC levels. So I think that also is going to help quite a bit in your field as well.
Well, that's really great news. So let's take a look at a demonstration of using Microwave Office on the VectorStar with some filter design, going back and forth between simulation and measurement and trying to combine the two in a very dynamic way so that designers can get the most out of what they're trying to design and folks on the bench can get a better understanding about what's going on with the actual things that they're measuring. In this demonstration, we're going to look at how the combination of Anritsu's VectorStar VNA and Microwave Office can be used together on the VectorStar platform. VectorStar is a brand new VNA from Anritsu that combines incredibly broadband performance capability with a fast measurement as well as a very high dynamic range, 100 dB approximately, which is very exciting for those of us in EDA because there's a very, very high dynamic range in simulation. We're basically limited by the digital precision of the processor. So to have a piece of measurement equipment that can give us very high dynamic range allows us to compare a lot of things measured versus modeled that we may not have seen previously. In this example, what we're going to do is design an a low-pass filter, an LPF, and that LPF has been fabricated. We're going to design it on the VectorStar. We're going to measure it with VectorStar and then bring those measurements back in to Microwave Office right on the VectorStar platform and compare our measured versus our design and then analyze the design a little bit to try to bring the performance back in line with what we're actually measuring, try to understand what's going on a printed circuit board. VectorStar is a great platform for doing this because you can run Microwave Office simultaneously with doing the measurements. So here's our low-pass filter in a schematic called design, very simple design here. The measurement is, or the simulation is shown here. We're getting about a 2 gigahertz low pass filter. Now, I've already gone ahead and taken the measurements, so I'm not going to trouble you with how to do that on VectorStar. I just want to show you how it works together with Microwave Office. To pull it into Microwave Office, we go to the data files object on the project palette, right mouse click, and just go into the import data file. And on the VectorStar, I've saved my data file, my 2-port S parameter file to a file called measured data, and we'll import that, and now we'll do some simulation and go over to our comparison of measured versus modeled. So what's going on here? Well, we can take some guesses. Two possibilities or two very high probable events that are occurring here if we look at our measured curve versus our design curve is, first of all, we're using real components. 0603 parts, 0402 parts for surface mount passives have package resonances associated with them. And we see a little resonance here, right sort of in the neighborhood where you'd expect to see these for some 0402 parts perhaps. Now, the resonance can vary based on the package size, based on the vendor, and based on the substrate material. We're measuring this on FR4. So that's going to be one effect. The other effect is that in our original design, if we go back to the schematic here, we have just short circuits or just wires coupling those components together. Those are real traces on a PC board when we fabricate this thing. And so those things are going to introduce loss or mismatch that are going to impact our performance. And my guess is that as we delve into this design and look at it in a little bit more detail, that those things are going to be a factor. So how do we do that? Well, one of the things that I've done is I've set up in the measurement analysis, I've taken that starting point schematic, and rather than just using the wires as short circuits, I've gone ahead and included those as AWR inets in the layout, and then use the extract feature so that these wires right here, these traces on the PC board, are actually going to be extracted to Axiom. A broadband EM analysis is going to be run. Here's the extraction, and you can see that ports are inserted in between our surface mount passives so that we can reintegrate this automatically into the design without having to go back to the schematic and stitch in a 6-port S parameter file among our surface mount passives. So we run the EM analysis. I've already done that. And if we go and look at the results comparing all three, here's our design curve, here's our measured curve, and here's our modeled curve, where I've also included in the measurement a model for the inductors that includes a package resonance. So you can see that package resonance is occurring here, and the line losses that we're getting due to the INET analysis, the Axiom analysis of our interconnects, is introducing that little bit of extra loss that we would expect. So this is some of the things that you can do very easily by coupling VectorStar with your design. You can play off between the design and the measurement data, and then try to understand your design in a little bit more detail by incrementally adding some of these effects, like actual parts with package resonances, and the effects of lines, or the coupling among lines by doing an extract step in AWR. This is a very powerful capability, the combination of VectorStar and Microwave Office, in terms of doing design like this, or even designing fixtures, or just doing a little bit of extra understanding of your de-embedding about what's going on there. If you'd like more information about VectorStar, I encourage you to go to the Anritsu website. If you'd like more information about AWR's extract capability, about real vendor parts for package models like the resonance here, you can go to AWR's website at www.awrcorp.com. And if you'd like even more information, I encourage you to contact your Anritsu or your AWR sales professional.